Okay, so today we are going to be talking about HTTP and AJAX. Don't worry about AJAX right now, but before we dive into talking about HTTP, who knows how does data get sent, or can someone describe how a piece of data could be sent on the internet? Yeah, Jim.
You can choose to send it to them via a form or ask to have it sent by request.
Okay, yeah, that is one. Those are some use cases. So forms and requests. We won't really worry about forms at the moment. We are going to kind of see how requests work. So with the internet, there are strict rules on how applications can communicate with each other over the internet. And these rules are called protocols. So yeah, so these protocols pretty much define different types of rules for different layers of the communication. And so it's not one protocol that governs the internet and how data is sent back and forth. It's a few layers of protocols. So let's start off with IP. Who knows what IP stands for?
Internet protocol?
Yep. Internet protocol. So the internet protocol is mostly, it is mostly concerned with where the server is, or server or computer is. Does anyone know what an IP looks like? Is it a bunch of numbers? It is. So IP, there are two versions. So IP version 4, and then there's also IP version 6. So IP version 4 we've seen before. It's 4 numbers, let's say .0, .0, .1. So it's 4 numbers that are separated by a period, and they denote a server's location or computer's location. And it's pretty good. It can, I don't know how close it can zone in on a computer's location, but it can at least triangulate a zip code. For IPv6, it has 6 of these, so it has a few extra fields. And a lot of people, there is currently an effort to go to the version 6 versus version 4. And this is just because version 6 has more places to hold more information pretty much. And there is a very big possibility that sometime in the near future, you will see this switch. So definitely in your guys' careers, we will see this switch over. So yeah, the IP is concerned with where the server is, and the location is described like this. We've mentioned it before. It's like an address, like a home address. And also ports are like an apartment address. So this is how you denote a port. So yeah, whenever, yeah, I was gonna give an example of IPv6, but let's see, host. So there's a terminal command called host that you can check that gives you an IP address for a domain name. So if I say, let's go to Google, google.com, it tells me that it has this address This is its IP address, and then this is the IP version 6 of it. So this is an example of what it would look like. So I'm just gonna paste that in there. So usually when we go to a browser and we say google.com, if I put in google.com in here, the browser will find the Google server IP address pretty much. And the way that it can find it is through this thing called the domain name system. So DNS. So the domain name system is pretty much a bunch of servers that have information on servers and IP addresses. So whenever you put in a domain name, it is able to route you to where that address is. We'll talk about DNS later on, but just be aware that it exists. So DNS provides an IP address from a domain name. Okay, so that's the gist of IP. You just need to know that it's concerned with where the server or the computer is. And that is the main thing. I was going to try to turn this one off. All right, so the next protocol that we will learn about is called TCP. Does anyone want to throw out a guess of what this means? Luigi?
Isn't like a transfer protocol or something like that? Or
so it is transmission control protocol. So this one is not concerned like the IP with where the server is. This is concerned with how the data is getting there. So how data is getting to where it needs to go, pretty much. So this protocol pretty much defines a way to package your data and send it over. So within this protocol, you'll have information like source IP, destination IP, it'll have the data itself, it'll have a bunch of other things. So this is, yeah, it's just the way that we should be sending data over. So this provides a reliable, ordered, and error check delivery of data streams. So if we're sending in data from a client to a server, it has to do something called a handshake, a three-way handshake, where the client sends to the server like, hey, I would like to make a request. The server is like, oh, hello, welcome, whoever. So that goes back to the client, and then the client says, okay, I accept this connection. Let's now do the data transfer, and then the data transfer happens. So it is a little slower, but that means that it's more reliable. It has error checking. So if you have a lot of data that you're sending, it packages that big amount of data into little packets, and it sends these packets one right after the other. And if one of them is missing, then it'll say like, hey, I didn't get this one, please can you send the data again? So it's a pretty cool way that it does the error checking. But yeah, so it's a little slower since every single connection requires multiple requests to initiate. But like I said, it's more reliable. So TCP, sometimes you hear of like TCP/IP. together as one protocol. It's just because they were developed together, and yeah, people use that as this is the way that interactions happen on the internet. Any questions on these? Okay. So we have the IP layer, we have the TCP layer, which is the actual networking. And then we have on top of that, the HTTP layer. What does HTTP stand for?
Hypertext transfer protocol.
Yep. Hypertext transfer protocol. So TCP is only concerned with how the data is transferred, but not with what is transferred or how that data is formatted. So the formatting of the application data is determined by HTTP itself. And I will move on to slides because we love slides. I don't love slides. So HTTP's web protocol. Let's present it actually. Okay. So the protocol was originally described in 1991, and it pretty much just said, it started with hypertext pretty much. So before HTML was HTML is the modern equivalent of hypertext. So HTTP was originally designed as a protocol for transmitting hypertext, which the modern equivalent of it is HTML. And even though HTML has grown to more than just linking one page to another, HTTP has also found new use cases. So it transmits HTML, but it also transmits images, CSS, JavaScript, API responses, all of that stuff. So anything that you see in here. So if I'm doing, so anything that I type into the browser up here, that will end up being an HTTP request. So if I look up google.com, this is an HTTP request to Google. If I had an image URL here, I could just paste it in here and it will give me the image, which is pretty cool. Okay, so HTTP usually describes a conversation between two parties, a client and a server. And we've talked about the client-server relationship before. So the client will send an HTTP request to the server, and then the server will respond with whatever is appropriate for that response. So both of them are both the requests and the responses are plain text, so you can actually just read them on just read them. They're human readable, and they have a very simple structure, so it's pretty easy to parse. So this is what a request looks like. So we have a request here, we have the host, and then a user agent. We'll get into exactly what these mean. And this is what a response would look like. So it gives a status, it gives certain information, so like content length and date, and content type, and then it will spit out all the information in the response body. So, so yeah, this is our request. This is the request line. We have a few different methods. So this is asking this, whatever server it is, to get this file using HTTP version 1.101. I'm not sure if there are other versions. I think all are using 101. And let me show you what this looks like. So you saw we did the Google request. So if I go to my network here, I'm going to refresh. So always when you go to a website, the first one is your main HTTP request. So this one, well, it's a HTTPS, but S just stands for secure. So it's a secure version of HTTP. Same functionalities. There's a little extra stuff, but we'll talk about that one later. So the method here is get. Get means I would like you to fetch me some information. So up here gives you like a little snippet of what the request is. So our request URL is this, and then the status code that was returned is 200. So to see the actual response that the server came back with is this. So this is the actual Google homepage. So this is what the server responds with. And yeah, this was the request that we gave. So for this request line, the first part of it is the method. And then second is URI. And then we have the protocol version. We have quite a few, methods. These are the most common ones. I think there's one, maybe there's more, but these are the ones that we typically use. So we have get, post, put, and delete. Get, you usually send out a request with get to retrieve information. Post is to send information. So if you're, let's say, creating a new user and you want to send over user information, that would be with a post. Put is to update a resource. Some people use post and put for the same thing. Oops. And then delete is for deleting a resource. So the way these methods actually work is the person who is sending the request will have to choose one of these. But then the server has to take this and do something with it. So we'll learn more about this when we talk about APIs, but pretty much whoever worked on the program that handles the server requests will have to say what each of these does. So these are more like guidelines. Not everyone follows the guidelines, but you should. And again, we'll get back to this. It'll make more sense when we see it in practice. Also, if you guys have questions, raise your hand. Okay, so for the second part of this, the URI, URI is Uniform Resource Identifier. So it isn't necessarily so it's not the URL, it's not the, so URL is all of this information here. URN is your host. So your host is your domain name. And then URI comes after it. So everything after the slash is considered a URI. So if you're trying to pull just this one HTML page, all you have to do is get slash this, and then you can put the host as whoever the host is. So this one, you're getting the actual resource or page that you're looking for. I kind of just went over this, but so this is how it's typically organized. A URN, host plus the URI, and then URL is all of them together, is including the protocol, which is HTTP // Okay. So typically the top part, this is the request line. So this is what you actually request. and then you send in headers. So the data, think of it as just bits of data. And so usually there's a header, and that header will contain information that the server will use. So here we use the host to actually find where our data is supposed to end up, or where our request is going to. And then our user agent here is to tell the server where we're coming from. So we're coming from like a Google Chrome browser. So something actually kind of interesting is that it turns out that most browsers simulate all the browsers, like all browsers that exist. So here for user agent, when we sent that request, it has Mozilla, it has Apple, which is Apple, and then Chrome and Safari. And so it tries to include it, or be included in all features that could be specific to specific browsers. Yeah, I'm not sure why this has become the norm, but yeah, that's interesting things that browsers do. Okay. So some requests have just the request line and a header, and this will be usually our GET requests. When it comes to post, you're actually sending over data. So that request will have a body, and that body will have information in it. So see here, the request is a post. Headers are pretty much the same. The content type header just says what the type of the data that we're sending in. And then there's a blank line, and then the body is afterwards. So, like I said here, so request bodies are most commonly used with post, put, and delete. I patch as well. I don't think we'll ever come across the patch request. But yeah, so it can include any sort of data. So the data that's sent in here, these are called query parameters. So this is the way you can send, this is one of the ways that you can send data through an HTTP request. And that is just to put it in as query parameters. This could also take the form of this. So if I wanted to send query parameters here, I think I have to put, it's over here, okay. So if I'm doing get/search, any query parameters that I want to add onto it, I can just put inside the same URI line. So I don't even need to send anything in the body. I can just send it in the top part of the request. So to differentiate between the domain and resource that you're requesting and the variables, was it a $? No, it's a question mark. So question mark, and then you put your variables. So my query equals something, and then to put another variable, you put the ampersand, and then color equals red. Yeah, questions about this? Or no? Okay, you can't put string characters usually. I don't think it's an acceptable thing to put in the URL. But yeah, also if you put spaces, it's going to be formatted differently. So this %20 is a space, just so you're aware. We're probably not going to use a lot of query parameters, but just so you're aware that they exist. Okay. Yep, that's exactly what I said here. Let's go to the next one. So these are example headers. So we have the host, which tells the web server which domain the client is requesting from. So a lot of times you will have the same server hosting your client and your server. So you will both be sending out data and hosting the client interface that the person is working with. So sometimes the host will be itself. Yeah, so you can also add accepted languages, the user agents, and what type of data that you are interested in receiving. A lot of times when you get back data from an HTTP request, if it's not a website, it would probably be in JSON. JSON is a JavaScript object, pretty much. And it just sends data that way, but we'll get more into that when we talk about APIs. Okay. Okay, so similarly to the request, the response also has the same format. So you have, so the first one is the status line, and then you have your headers, and then you have, after a blank line, you have your body. This is just how it's always formatted. So it's easy to understand or parse what that information means. Okay. So when we get a response, we always get a status code. So 200 tends to mean that whatever happened was a success. So there's a status code, a reason phrase, the version same as before. So some of the ones that we would see are okay, 302 is a redirect, 400 is a bad request, 401 unauthorized, 404, which we've probably seen a lot, not found, and 500 is an internal server error, which you guys will probably trigger a lot when we're working with Django. But yeah, this is just a generic error saying, I don't know what happened on the server, but something went wrong and we weren't able to process your request correctly. There's also another list of status codes. Yeah, here on Wikipedia. So the 100s are usually informational responses, which you might not see too much of them. 200s are success. Anyway, it's a little bigger. 300s are redirection. 400s are client errors, and then 500s are server errors. So these are the most common ones, and then it kind of goes through the types that you would see. So like the 201, your request was fulfilled, and you're good. So created, accepted. A lot of times people just send a 200 to be like, okay, this is a success. Redirects. 304, not modified. So this one, if you've been to that website before and the information is cached, so if you have like a cookie or something like that, which we'll go over, it's a whole other lesson. But you guys have heard of cookies. It's kind of information that the server tells you to hold on to. And then when you go to that website again, the server will have access to those cookies and will see when you've been there last, which is pretty cool. So if 304, if you've been there, if the last time you've been to that website, the content has not changed on that website, you'll get this and the content will not be modified. So it'll just kind of load up the same version of it, which is kind of cool here. So if let's see. So for this one, yeah, I don't know if this one would work. I need a different website. Any website? Amazon? I don't know. Okay, so now if I refresh or not. Yeah,
What
it
about
would be
the
something.
Wikipedia page we were just on?
Oh, true. Simulated, yeah, there we go. So when I refreshed again, we got a status of 304, which is because we were just here and we didn't need to load the information again. So all the way over here, there's cookies, and it shows you what kind of information Wikipedia is using to identify the session. And you can see this with whatever website you go to. Yeah. Okay. Okay. So response headers, these headers have a similar purpose as the request headers. They provide additional context that the client uses to interpret the response. So you can send over the content type, content length, set cookie. So if you want to set, if you want the client to save a cookie, then you will send it over with, this is the response that's coming from the server, right? Also the date. These are some of the most common ones that we've seen. Okay. So many different HTTP conversations happen. When you're loading the initial homepage of something, you get at least one request and response. Then when you're loading the CSS, you're getting an HTTP request, and then you're loading a CSS file for every response that you get. Same with JavaScript. So in the network tab, you always see like all your requests. So all of these are different requests. So these are font files. This is a script file. These are SVGs, which is a form of, I think it's vector images. You have, yeah, fonts, images, all that fun stuff. Okay. So generally the conversation between the client and the server is stateless. So the server won't hold on to any client information. So if you ask a server to give you data on like a list of animals, and it gives you the first 50 animals, and you go back to the server and be like, hey, can you give me the next 50? And it'll be like, next what? I don't know what you're referring to. So you would have to say, give me page 2 of the data that you're giving me, of animals or something like that. So yeah, the server does not hold on to any state that happens from a request. But with the exception of cookies, so cookies, like we said, the server will send over to the client what cookies they want to keep track of, and it tells the client, hey, hold on to these for me. And then when you visit that website again, you'll send over all the cookies that you have. And that will give the server information about your visits. So cookies enable, it's how you know, like if you're shopping and you have a shopping cart that you're filling on one tab, and then you open a different tab and or you close that tab and you open it again, it'll keep track of the fact that you were logged in and you were doing whatever you wanted to do. So yeah, that's cookies. Yeah, I already went over this. Okay, so HTTP has been used and will continue to be used for the foreseen future. I'm not sure if there are efforts to replace it, but it's working. I mean, HTTPS has replaced it because everyone wants to do secure stuff on the internet. So yeah, so it's been around. It's relatively simple and human readable. It pretty much allowed people to get connected to the internet and be able to contact a server and receive information pretty seamlessly. So that's why it's cool and important. Okay, so that is it for this.
I have a question.
Yeah.
How often do people depart from these standard settings? They seem like they're things we would almost never change.
Yeah. So some people, so like I was mentioning with the requests, like when you're creating an API, if you're the one writing the code that is on the server that makes the responses, it's kind of up to you to adhere to these rules, you know. So some people, like I was saying with the request, where is it? Yeah, with the request types, some people use post and put as the same thing, when usually you're supposed to do the different thing, or they're supposed to do different things. Can't talk today. But yeah, generally these are all guidelines. I think with the way the structure of the request and response are, that is pretty streamlined, like that everyone follows that. But yeah, it's little things with the status codes and stuff like that, because you won't actually be handling writing a response like this. Your response will just be data, and we'll see how to do that, but it's pretty much you're using separate libraries that allow you to make these requests and responses. Other questions? Okay. I know it's been a long day. I will quickly chat about one little thing, and then we can end the lecture. Who has heard of APIs? I know I just mentioned them, but can someone tell me what an API is or what it does?
Isn't like a contract that you can use their program, but yet you still need to like create the actual functions themselves?
Kind of. So with an API, it's pretty much a way that it's also one of those. So let me start up again. An API, first of all, stands for Application Programming Interface. And the most important keyword here is the interface. It allows you to speak to a server, but it has certain rules on how that conversation can go. So companies that have data, they or some companies that have data, they create APIs, they create an interface that allows you to send an HTTP request to their server, and they will send you information back. And that is kind of like the gist of what an API is. So when we're sending a request, we have our domain, we have like our main URL, we have whatever resources we're trying to get, and it will send us back information. So we'll see this tomorrow. We'll actually like code and work on APIs. But there's a Pokemon API that we're going to see tomorrow. And this is the base URL for the request. And then this is the resource that we're trying to access. And pretty much whoever created this API is telling us, this is how you can access our data. So if you put this information as your request, we will send you back this information. So it's just a data dump of information on Ditto, one of the Pokemons. But yeah, we'll see that more in depth tomorrow. Any other questions?